functions for graphical representation of the data or the results which we achieved after applying some R functionalities. And then we can also plot different kinds of charts to represent that information so that we can share the analysis with others. Right? So the purpose of graphical representation is to represent the data, because it's very difficult sometimes to read a huge amount of data written in a tabular format. So it's better to generate graphics out of that or plot the data with respect to 2 parameters or 3 parameters, so that we can get an analysis of the variation of one data with respect to the other data in a graphical manner. Right? So R provides there are different kinds of facilities, or you can say plots, which we can create or design in R. For example, we have these are some of the common plots which are there in R: the step charts, histograms, time series plots, scatter plots, box plots, and pie charts. I hope some of you must be aware of some of these plots earlier also, because we are working on some of these plots since our 10th or plus 2, and we have been creating such kind of plots earlier also. But in R, how we will create that, there are different functionalities which are there in R, which would help us to basically create all these kinds of charts in a very easy manner. So one by one, I will take up all these charts and explain you the various kinds of charts that we will create. So the first is the step chart. So a step chart produces one-dimensional scatter plot, or it is also called dot plot. So it is a one-dimensional scatter plot of a given data, mostly in a straight line. Right? So these are the plots are good alternative to box plots when the size of the data is small. Right? When the size of the data is small. So if you have a limited amount of data sets, and it's better to stretch out a chart of that data. So there is a function called step chart function. By using this function, we can create step chart in R. So it takes a numeric vector or a list of numeric vectors and draw a step chart for each vector. Right? So in a single chart, we can create multiple charts by giving different vectors into it. Right? So basically, all these graphs, they can work with single variable, two variables, and multi variables also. So strip chart is one kind of graph which basically represent the data in a strip manner, in a straight line. Right? And we can have more number of vectors or more number of variables into a single step chart. So how to do that, I will also explain with an example. Right? So move to the R studio so that we can have practical demonstration of this. So my R screen window is visible to everyone. So here, what I will try to explain you the way to create these charts by using the various functions which are available in. So first of all, because our step chart creates a one-dimensional scatter plot of a given data. So first of all, let's create some dummy data. So I will create one vector V, pass some values to this vector. Pass some values to these, passing to this particular variable, getting a list of all these variables. the various variables which are values which I have created in this list for the variable v, right? So the simple way to create a step chart is to just give step chart here as a pop-up, and then you pass the vector into this. He is my vector, so the vector is enter, so it will create a vector like this, step chart like this. Right. So you can see that there are number of entries, but here it is representing only few boxes. Right. Why so? Because if you see 12 is repeating twice. So on 12 we have a box which basically represent two values. So that's why there are less number of rectangles in this particular step chart as compared to the data element in my vector B. But we can customize this because it's a blank chart, so I can give various parameters to it. Let's first give a title to this particular step chart. So there is a parameter called main. In main I can write my chart. Right? So run this, you can see my chart appears at the top of this particular graph. Similarly, we can use other parameters also, like we have x lab label, which is the x label on the x-axis. And so let's say I'm just assuming giving some random values, label, then y label. Again, I'm using some words for these. So you can see values appear on the x-axis and points appear on the y-axis. I can also change the color of this box. So now you can see the color of this has been changed to black. Right? Then here you can see there are number of entries, but here we have only few entries. So we can have a variable called jitter. This is a method called jitter. So we will set the method to jitter. You can see all the entries, they have been represented by some displacement. So jitter is a method through which we can do some displacement in my data points in the graph. Right? So again, there is another property which is a Boolean property called vertical. Also represent it in a vertical manner by setting it to true. Now you can see these values, they will be represented here as in a vertical form. These are the various properties which we can add into it. So this is this is a step chart with single variable. So I can add more variable to it. So let's create one more D with some values and just values just to various values. Now I have two vectors. You can see there are two vectors. One is this vector b, and second is t. So now you have to concatenate these two. So I will create x as a list. First, because these are two vectors, so the name of my first vector I am giving as first, and is b. And second I am giving as second, and the vector which it will represent is t. And so I have created one list. Now there is a list of two. It is created. Now I will use the same method, step chart, but instead of x, I will pass x to it. Rest all I will not change, but definitely because here let's first run this. step chart. So I will remove this. Then if I press enter, so now you can see there are two steps here. One for the first and second for the second. So these are two steps. Now here you can see the color of both the steps is red. So I can change that also by passing values into this color. Try to have this. Run it again. Now you can see there is a change in color for these two. Now you can see we have a clear bifurcation of these two steps on the basis of their colors. So there is another parameter PCH, which we can set because these are the parameters of general graphic formatting of the general graphs. So we can use them in all our charts or plots. And so if you see now this rectangles, they are changed into circles. And so we can experiment with by passing different values here, and you can see the changes over here in the in my step chart. Okay, so this is one kind of chart. Now the second kind of chart is our histograms. Presentation. Next is the histogram. So it is a bar graph like representation of the data that buckets a range of outcome into the column along the x-axis. Right? So I think everybody knows about bar graphs also, where we represent data in the form of bars like this, right? The x-axis. So a histogram is used for variables whose values are numeric and measured on an interval scale. So we can measure them as per them. So like frequency distribution is there, we can represent that with the help of this bar chart. For example, in the year, let's say 1920, how many doses were given of polio were given to children. So and then next year. So it will give you the frequency of that. So in this x-axis we have here, in the y-axis we have number of doses like this. Or we can create a histogram of number of doses given, COVID-19 doses given to plus 44 people in every month or day. So like this, where we have to represent some kind of distribution, we can use this histograms. And so they are basically used to deal with the large data sets. So it can also helpful in detecting the unusual observation or outliers. Outliers are those observations which lie, let's say we have a data set and the value of the data set lies between, let's say for the COVID-19, the daily basis, how many vaccinations have been done. It lies between, let's say 100 to 200. But on a particular day, there was only 10 vaccinations. So this is our outlier. Whereas on all other days, the vaccination is between 100 to 200, but on a particular day, the vaccinations were 10. So that becomes our outlier, which is an unusual observation. Right? So there is a function called hist. By using this functions, we can create histograms. It takes the vector of values for which we would like to plot a histogram. And so let's move back to the R Studio. And so this is the syntax of this function. Hist. It takes different parameters. V is our vector, main is the title, X label is the label on the X side, then X limit is the limit that we would like to put on the X axis, and then Y limit LIM is the limit we would like to put on the y-axis. Then breaks is the number of your bars, that is our breaks. This is our color, and this is the color of the bottom. And so these are various parameters which we can pass, but minimal we require this much. Histogram, the vector for which we would like to generate a vector for which we would like to generate a histogram. So let's move back to the RStudio. I will show you the various versions of this histogram. Create a histogram of P, a simple method, just by passing this value. So now you can see it has generated the histogram and automatically divides that into a range 10 to 20, and these are the frequency. From 10 to 20 there are 4 elements, then 12 to 4 there are 2 elements. Likewise, it has generated that histogram for each and every value which lies between that particular interval. Now similarly we can pass various parameters to this. We can give name, my histogram, defined name you can give. So if I run this, it will display my histogram at the top of it. Similarly, you can give x labels. X lab is equals to interval, and you can specify the color also. Let's red. If I run this, it will generate accordingly. Okay. So this shows the frequency distribution if by default, but if I can set the frequency to false. Okay. So let's do this. Value to false. Now you can see it shows the density distribution. Now the frequency is changed to density. So this depends upon which kind of histogram you would like to create, whether you would like to have a frequency of various intervals, and that means the count, or you would like to have a density. So it automatically, just by changing the value of frequency to false, it will convert it from frequency to density. Right? So this is all about histograms. So histograms also return few values. It also returns various components. Like if I let's say create a variable h. Let me first create a variable h here. Pass this histogram to this h variable. Now h, if I type h, it will display various components here: the breaks, right? The count, the density, the mids, the x name, EQ distribution is true, and the true class is histogram. So these are the various components. So these are the various components which are returned by hist function. Right? So breaks, places where the break occurs. So it will display all those values. Count means the number of observation falling in that particular cell, then the density of the cell, then the x name of the cell, x argument name, and this is the last equidistance, a logical way of indicating that the breaks are equally spaced or not. We can create breaks with a different spaces. Like here, if you see in this chart, every break is of equal size. Here you can see 10, 12, 12, 14, 14, 16. So every break is equally placed. But we can create a non-equidistance breaks also by setting this property to false. Right? So what about histograms? So the next is time series plots. Right? Okay, this time series plot is a special kind of plots which basically plots each point associated with its timestamp. Right? So which here in the case of time series plot, we represents the various data point with respect to the time of generation of the data. Right? So there are many functions to create, manipulate, and plot the time series data. Here in this lecture, particularly, I am discussing the bare minimum which is required to work with these plots. No doubt, we have many other parameters, many other options that you could pass to these functions, and you can generate different kinds of plots as per your requirement. But this much is required to know before going into the more detailed or more complex kind of plots or charts. Right? So this is what I am discussing, the bare minimum which is required to generate plots in R. Right? So in R, if you would like to generate a time series plots, we have this TS function. So one thing more, the data of this time series is stored in R object called time series object. It is just like vector or the data frame objects in R. So if you have a time series related data, then the object is called time series object. Okay? So it is created by using this TS function in R. So the syntax is we have to specify time series dot object name, then TS, and then some parameters are there. So these are optional parameters. These three are optional, but data is required. And so you can give start and end value and the frequency. I will discuss what is the meaning of frequency here. So data basically is a vector or a matrix containing the values which we would like to use in time series. And the start and end, they are the start time for the first observation and start end time for the last observation in the time series. And frequency specify the number of observations per unit time. Right? So there are different values of frequency that we can specify. Well, is the data, if I specify frequency is equals to 12, right? So that means the data points for every month of a year. If I specify frequency is equals to 4, that means the data points for every quarter of a year. If I specify frequency as a 6, so that means the data points for every 10 minutes of an hour. And if I specify 24 into 6, so that means data points for every 10 minutes of a day. So this is for 10 minutes per day. This is 10 minutes, data points for 10 minutes per hour. This is quarter of year, and this is every month of year. So we can specify these frequencies as per our requirement. Right? So let's go back. So we will now move to the R Studio to see how we can work with time series. Okay. So let me copy some data, because here I have to generate some data which is related with the time series. So let me copy the data I have already generated. So this is one list vector I have generated, which is called rainfall, which stores the amount of rain year wise. Right? So this vector I have created. Then I will create time series. real time series object by passing the values to this particular. So this TS data is our rainfall. Start is year 2020, 2012, and end is 2020, and the frequency is 12. So after this, you have to say plot. Plot is a general function which is used to plot the curve. So now you can see this kind of time series plot will be generated. And so if you don't specify this frequency, or let's say just pass this value to this, so if I run plot, now you can see a different kind of plot. And so in this case, it was very specific to the start and then the frequency. So let's remove this frequency also. See, starts from 2012 and goes up to 2020, and this side we have rainfall dot time series, which says the rainfall in every year. So accordingly, if you change the value of the frequency, it will generate a different kinds of plot. So see, it is generated different kinds of time series plot. So it depends upon the various parameters that we will pass into this function. So you can create different plots accordingly. So next, after this time series plots, we have scatter plots. So scatter plots shows many points plotted in a Cartesian plane. Right? So we can represent it like this. We have different points which are represented in the plane where we have x-axis and we have y-axis. It represents the relationship between the x and y. Right? So one variable is chosen in the horizontal axis and another is on the vertical axis. So we can represent the relationship between the two variables by representing on different axes. So there is a simple, we have a scatter plot created with the plot functions. I will again discuss this plot function at the end because it's a very important and general function in R to generate different kinds of objects depending on the values which we will pass into this plot function. But here this plot function we are discussing to generate the scatter plot. So there are different parameters that we can pass x and y. These are the two variables that we require. Then we know what is the main. It is giving the title. Y label is it is used to give the label from the y-axis. X-axis. Y label is used to give this. X limit and y limits are to limit the data points within this particular range we will specify in x limit and y limit. Okay. So let's go back to the R. Now we will use one data set which is empty cars, and we will generate scatter plots by taking two, because here we require two variables. So I will use the empty cars data set because we all have worked on that data set also. So we will take that data set, pick two variables from that data set and try to generate scatter plot of two variables. So I have already written those statements. Replace them just to save time. So this is, I have taken two variables W2 and MPG from there. So if you want to see what the head values of this first 5 values, so you can specify print head input. So because input contains the data, then we can specify the plot. Here we will say x is equals to, because input contains two parameters, one is WT and second is MPG. So what x represents? So x is equals to input $W2. So this dollar, we know what is the purpose of this dollar. because we have done some experiment on this. Then y is equals to input $mpg, x label I am giving as weight, y label as mileage. Between 15 and 10, and then giving a title to this particular scatter. I press so let's create a graph to this point. Now you can see there is a scatter plot which it has generated. I have not passed any extra value to this. I have just passed two values, x and y. So x, it is representing variable name with this with the same name which I have given over here, input $WT, input $NPG. Now let's customize this. So x right is weight, label is on this. Now you can see this has been changed. Now if I limit these values between 2.5 as per my previous command, so let's limit that value. It means it's the value of x between 2.5 I limit goes to C. Also give a title to this, which is weight versus mileage. So if I this, now you can see all those changes. Earlier the limit of mileage starting from 10 and it was starting from 2. Now as per my limits on the values of x and y, now they are starting from 2.5 and ending up to 5.0. Here they are starting from 15 and goes up to 20 as per my limits. And so all those things I have customized here. And similarly, we can create a scatter plot matrix. Right. So then, like in this case, we have only two parameters to generate the scatter plot, and to show the relationship between the weight and the mileage. But if you have more than two parameters, right, and you will like to find the correlation between one variable versus remaining variables, then we can create scatter plot matrix. Right. So for that we have a function called pairs function, which creates matrix of scatter plot. So the function is pairs. Of the function through which we can create a matrix of scatter plots, and within that we can pass two things, formula and data. These are two things that we will pass. Where formula represents the series of variables used in the pair, and the data represents the data set from which the variables will be taken. Now in our case we are using this empty cars data, so data set will be empty cars and the various variables which are defined in that particular data set. I'm going to consider all those variables. So let's say 4 variables are there, so one variable versus 3 other variables, so total there are 4 variables. So this is the syntax. So here pairs, I will pass on the various value with tilde WT plus MPG, one variable, plus displacement is another variable, then select. Then we have data is equals to empty cars. Data set, then main is equals to now you can see if I create this, it will generate this kind of plot where it is one versus other, MPG versus other, displacement versus other, cylinder versus other, weight versus other. It will show that scatter plot. So if you have requirement like this, then we can create a scatter plot matrix where we will compare the one variable with the rest of the variables. Right. So here we have 4 variables, so it will generate 4 by 4 matrix, where the first element, first matrix belongs to that 1 is belongs to the first variable, 2 belongs to the second, 3 to the third, 4 to the fourth variable, and the rest of MPG, displacement, and so the various variables. Then we have block plots. So, sorry, box plots. Box plots are basically used to measure the distribution of the data in the data set. Right? So how well the data is distributed in the data set, if you would like to see, then we can create a box plot of that. So it divides the data into 3 quartiles. Right? So 3 quartiles. So it represent minimum, maximum, median, 1 quartile, first quartile, and the third quartile in the data set. It is also useful for comparing distribution of the data across multiple data sets by drawing the box plots for each of them. So how well the distribution of the data is there across data sets, if you would like to see, then we can generate box plots. And so box plots are created in R by using box plot function, where we can pass different parameters: x, data, notch, variable with names, and names. So these are the various parameters that we will pass. Some of them now we are familiar with because we have already seen some of them. So x is basically a vector or a formula. Data is your data frame. Notch is a logical variable. It is basically used to draw a notch. Like we represent it like this. If you would like this, then notch it, then we can set this property of notch to true. Otherwise, it's by default it is false. Then variable var width is a logical variable. It is set to true, set as true to draw width of the box proportionate to the sample size. Then names are the group labels which will be printed under each box plot. So we will have different box plots and names that we will put on each box plot by giving this names property, and main is the title of your name. So I will just draw a simple box plot. For this particular variable v first, and then box plot for the data set. So here we will say v. So if I write this, so it will generate something like this. So similarly, we can add some properties to this. And we can have x label equal to x. And y label we can specify. Like to specify. So whatever you will specify, it will appear like this. Right? So then we can have box plot for, because we have 2 vectors here. One is v and second is d. So I will create box plot for v comma d. V comma d. So it will generate 2 box plots, for one for vector v and second for vector. Right? So let us now create a box plot for again for this particular empty car data set. So I will just copy the text command here. Then we can print the heads. We have already seen that. Then we will type the box. Here I will pass on the various values to this. And so now you can see it has generated that box plot for us. And here we have number of cylinders, here we have miles per gallon. So we generate box plots like this. So similarly, in case of histogram, it returns some components. So box plot also returns some values. So we pass. If I pass this value to P, so it will also return some value. So it will give me a matrix of this one, the stat, and the number of n. So all those variables are basically defined in R. Okay? So stats is basically gives you a format in the form of a matrix. N is the number of observations the box plot is drawn with. Right? So if I specify notch value in this, this, let's see what will happen. So now you can see some kind of notching is there, where some skewness of the images are there. So it's better not to use them when only you require to represent that data in this form. So all these graphs or the charts, they will be used as per our requirement. So if you have a requirement of box plots, then you can create box plots by using this particular function. Then we have pie chart. This is the last chart that we will discuss. It is a method to represent the division of the data in a circular statistical graphic. Okay. So we have function called pie function in R. This function takes in vector of non-negative numbers, and it will generate pie chart from those negative numbers, where here x is basically represent the vector that contains the numeric values. Then we have various label parameter describe the slices in each byte, because when we create a slice like this, so there are a number of slices, 1, 2, 3, 4, 5. So it will label all those slices. The radius used to indicate the radius of the circle of the pie chart. It varies between -1 and +1. Mean, we all know it is used to give names, a name to the pie chart. Then color, COL is to give color. Then clockwise is a parameter which is a logical value, which indicates whether the slices are drawn clockwise or in the anti-clockwise direction. So we can give like this. Go back to the R Studio to show this how it will work. Fine, so now we are back in the R. So let me copy the commands from there. So I have created one variable in R. Then I have given labels to this by using the labels. Then within the pie method, I will pass on the labels and the vector. So now you can see pie chart like this. And so by default it will give different colors to the different labels. So you can also change the color by specifying the rainbow length x. On the basis of this length of the various values in C, it will generate a rainbow kind of a thing. So this is another function which we can use to generate pie charts or to generate color. different color pie charts. Right? Otherwise, it would generate a chart with different colors as per the specifications. So if you would like to generate a pie chart with your own colors, then you can specify this. Okay. So then last function that I have already covered, but still we can do this. So it's a generic function. Okay. So it has many methods. Some we have already seen by using the plot. We have generated few charts on the plots, which we can generate different kinds of plots, and they are depend on the type of object that we will pass to the plot. So if I go back, and here you can see I have generated this scatter plot. Similarly, we can have different types of plots we can generate. We can pass vectors to that. We can set the different parameters into the this. We can generate plot for the sine function. Right? So different kind of things. So I will just show you few examples and a demonstration of this in our studio. So just copy. It will generate a sine wave like this, and give different parameters to this particular function. You can see I have given a name. I have given a name to the x-axis, label to the x-axis, to the y-axis by passing the various parameters. And so we have specified there is a property, the variable type in which can take different values. Like here it is I am giving L. And so it means we are generating line. So if I say generate points, so by changing the values of the type, you can generate different kinds of lines in your chart. Right? So you can experiment with all these things. Now the last topic that I would like to discuss quickly is how we can save the files. And so all the graphs which we have seen, they can be saved as a file on disk with the help of built-in functions which are there. Right? So we can save the vector images. The problem with vector bitmap is they are of fixed size. We cannot resize them, but by default there is a pixel length or the width and the height of the pixel which are defined, but we can change that. But if you resize those images, it will blur. But the problem with and the advantage of vector images is they are easily resizable, so it will not blur or scattered after resizing. Okay? So there are different kinds of functions to save the plots, like JPG, PNG, PMP, TIFF, and these are the various functions according to the type of file you would like to generate. If you would like to generate a JPG file, you will use JPG function. If you would like to generate PNG, we will use PNG function like this. And then we will have this def.off function at the end of this saving. After saving the plot, then at the end we will say that we will give this command def.off, right, after all the plotting, because it will save the file and return control back to the screen. Right? So this function is very important. So I will just quickly show you in MATLAB, sorry, in RStudio. Right? So let me open the file. So first I'm going to do is I'm I'm going to generate a JPG. So here I have to specify the name of my file. So let's go first .jpg function is this. Now what I would like to save is histogram. So I will get histogram of V. Then I will say this f dot off. So now if I go back to, because my default folder is my documents, so let me share my window. Now you can see there is a file my first, and if you see the dimension of this, it is 480 by 480. This is by default. If you create a JPG file, its dimension would be 480 by 480. If I open this, it will have the histogram of that V versus the frequency. Right. Similarly, you can pass different. You can generate different kind of images by specifying different kinds of file. So this is JPG. Similarly, we have PNG also. Within that, we can specify width and height of the image also. Right. Then for PNP also, for this TIFF also, you can pass. The syntax is almost same. There is no change. Right. One thing I would like to show is how to save a vector file. Right. Suppose I want to generate a vector file of this particular histogram. So for that, there is a function PDF. Do that also. To save some. Here I will change the name of this file, my first.pdf. Just we do this and say dev.off. Please see. Share the screen so that you could see. I share my documents. Now you can see there is a my first PDF file. So if I open this, it will generate that histogram program. So if I resize, now you can see, okay, I think this is not visible. 2 minutes I will take. So this is the outcome. Can you see this PDF file? So if I resize this, you can see there is no distortion of my image. Now I have taken up to 300. I have zoomed it to 300%. Still it is intact. So this is the advantage of this vector images. Right? Similarly, you can generate the PostScript with this. Right? So for that, we have PostScript function where we will pass on the syntax is same. You will pass the value of the file that you would like to generate. Fine. So here we have written post PDF. You can write PostScript. So now you can see there is a function PostScript. In this, we can again file in the file is equals to my PDF first.ps, because PostScript files, they are saved with the PS extension. So with that, we can save that, and then these two commands we can apply and see whether that file will be saved or not. End of this particular topic also. Thank you very much. I have already taken 2 to 3 more minutes.
Yes, sir.